Hello everyone. Good morning, good noon, good afternoon, good evening. I am here to talk about carbon as a source of energy. Carbon is a non-metallic chemical element in group 14 of the periodic table. Although widely distributed in nature, carbon is not particularly plentiful. It makes up only about 0.025% of Earth's crust, yet it forms more compounds than all the other elements. Let's talk about its origin. Carbon is a fairly abundant element produced, like most light elements, in the core of the stars by nuclear fission of energy. The carbon on Earth and other planets comes from a star that exploded before the formation of the solar system. Like all non-reactive elements, this initial carbon is permanently conserved and recycled since the formation of Earth, passing through different environments and combining with different molecules. Let's talk about their reservoir. This carbon is stored in different forms in media called reservoir. In the atmosphere, there are 860 gigatons. In the ocean, there are 38,000 gigatons. Biomass from the ocean, there are 3 gigatons. Land plants, there are 500 gigatons. In soil, there are 2,000 gigatons. Fossil carbon, there are 10 billion gigatons. And last but not the least, carbonate rocks, for a total of 17 billion gigatons. To sum it up, the ocean contains nearly 50 times more carbon than the atmospheric reservoir. However, a large carbon reservoir is found in calcareous rocks, form of calcium carbonate combined with magnesium in variable proportions. I have here examples of matter which has carbon on it. The first one is diamond. Next is a tree. The third one is a charcoal. And the last one is a leaf. Let's talk about evidences which pertains that carbon is a source of energy. Let's have evidence number 1. This article, climate solution use carbon dioxide to generate electricity. Sending atmospheric carbon dioxide into underground methane hydrates could clean the air and create revenue. The process includes pumping down airborne carbon dioxide down into methane hydrates where the gas would be permanently stored or sequestered. Methane hydrate is a large deposit of icy water and methane right under the seafloor beneath water 500 to 1,000 meters deep. Many methane hydrate deposits exist along the Gulf of Mexico, shore and other coastlines. Large power plants and industrial facilities that emit carbon dioxide also line the Gulf Coast. So, one option would be to capture the gas directly from the nearby smokestacks, keeping it out of the atmosphere to begin with. And the plants and industries themselves could provide a ready market for the electricity generated. Let's have evidence number 2. Scientists convert carbon dioxide, create electricity. Scientists have developed an oxygen-assisted aluminum carbon dioxide power cell that uses electrochemical reaction to both sequester the carbon dioxide and produce electricity. The title of their paper is The Oxygen-Assisted Aluminum Carbon Dioxide Electrochemical Cell, a System for Carbon Dioxide Capture, Conversion, and Electric Power Generation. This is through the efforts of Lyndon Archer and Waji Al-Sadat. They have developed an oxygen-assisted aluminum carbon dioxide power cell that uses electrochemical reaction to both sequester the carbon dioxide and produce electricity. The group's proposed cell would use aluminum as the anode and mix streams of carbon dioxide and oxygen as the active ingredient of the cathode. The electrochemical reactions between the anode and the cathode would sequester the carbon dioxide into carbon-rich compounds while also producing electricity and a valuable oxalate as a byproduct. The current drawback of this technology is that the electrolyte, the liquid connecting the anode to the cathode, is extremely sensitive to water. Ongoing work is addressing the performance of electrochemical systems and the use of electrolytes that are less water sensitive. Carbon dioxide is one of the major greenhouse gases. Most of this heat-trapping gas is produced through human activities related to burning fossil fuels, for electricity, heat, and transportation. Now, a team of researchers has announced a successful experiment that turned carbon dioxide into useful liquid fuel. Rice postdoctoral researcher Chuan Xia, the one on the left, and chemical and biomolecular engineer Haoshan Wang are the two researchers who created a device called a reactor that converts carbon dioxide into a pure form of formic acid. Formic acid is a substance found in ants and some other insects as well as in many plants. The big picture is that carbon dioxide reduction is very important for its effect on global warming, Haoshan Wang said. If the electricity comes from renewable sources, we can create a loop that turns carbon dioxide into something important without emitting more of it, he added. Let's have evidence number 4. Carbon capture to fuel is here. Svante Arrhenius was a Swedish electrochemist who in 1985 predicted that man-made carbon dioxide emissions would dramatically transform Earth's climate, and you and I live in the future he saw coming. Much of the blame falls in our transportation infrastructure. Around 20% of global carbon dioxide emissions are made by cars, trucks, airplanes, and other vehicles. Wouldn't it be nice if we could pull out carbon dioxide of thin air and create a vehicular fuel that's better for the environment? This is the carbon engineering's clean fuel, synthesized from carbon dioxide. With the help of Bill Gates, Carbon Engineering was able to open a $9 million direct air capture plant in 2015. The facility uses large fans to pull outside air through filters coated with liquid solution that traps carbon dioxide. Then, the captured gas is converted into small pellets of calcium carbonate. Using these pellets, Carbon Engineering has made synthetic gasoline, diesel, and even jet fuel. This is a very good example of sequestering carbon from the air and using it as a source of energy. Carbon moves from the atmosphere to the plants. In the atmosphere, carbon is attached to oxygen in a gas called carbon dioxide. Carbon moves from plants to animals through food chain. Carbon moves from plants and animals to soil. When plants and animals die, their bodies decay, bringing the carbon into the ground. Carbon moves from living things to atmosphere. Each time you exhale, you are releasing carbon dioxide gas into the atmosphere. Carbon moves from fossil fuels to the atmosphere when fuels are burned. Carbon moves from the atmosphere to the ocean. The ocean and other bodies of water absorb some carbon from the atmosphere. The carbon is now dissolved in the water. So you see, carbon dioxide circles around atmosphere, plants, animals, fossil fuels, and other human activities, meaning you are also a contributor of it. Carbon dioxide is a greenhouse gas and traps heat in the atmosphere. Without it and other greenhouse gases, Earth would be frozen cold. But since the start of Industrial Revolution, we humans have burned so much fuel and released so much carbon dioxide into the air that our climate has risen over 1 degree Fahrenheit. As I mentioned a while ago, there are evidences that carbon can be a source of energy. Those practices exemplifies carbon sequestration from different reservoirs and convert it into a reusable form of energy without increasing carbon footprints. This can be a very good example of removing excess greenhouse gases so that we can preserve Mother Earth. Here are some inspirational quotes for you so that in your own little way, you can help lessen carbon footprints for a better world. According to Gaylord Nelson, the ultimate test of man's conscience may be his willingness to sacrifice something today for future generations whose words of the thanks will not be heard. Another one, caring for the earth is not a hippie thing, it's a survival thing. True enough, right? Next, the earth is what we all have in common. So once again, this is Mary Joy Saltaria challenging you to make a difference because Earth is where you live, where we live, where they live, where you live, and this is where I live. That's all for today, and thanks for watching!